You can go with highest exponent, or you can just add your like terms and then organize it. So if you're looking at this, you're going to say x squared. What does that pair up with? That pairs up with the negative 6x squared. So x squared plus negative 6x squared plus 2x to the fourth. What does that pair up with? That pairs up with x to the fourth plus 6x cubed, which pairs up with the 7x cubed. Remember, if it doesn't pair up with anything, it just stays the same. And then once you do this, you need to actually add them. Positive 1 and negative 6 give you a negative 5x squared. Positive 2 and positive 1 give you a positive 3x to the fourth. Positive 6 and positive 7 give you a positive 13x cubed. When you are done at this point, now is when you want to organize them in standard form. So now I would say what comes first, second, and third. Here, highest exponent is the fourth. So this one is going to be 3x to the fourth, then the positive 13x cubed, then the negative 5x squared. And that would be my answer here. So this group here is multiplying, not adding. And so you don't have to worry about like terms, you just multiply all of them. So I'm going to multiply the 2x through first. 2x times 6x is 12x squared. 2x times negative 6 is negative 12x. And then I'm going to distribute the negative 5. Negative 5 times positive 6x is negative 30x. Negative 5 times negative 6 is positive 30. Then my last step here is to combine like terms. The 12x squared does not combine with anything. The negative 12x and the negative 30x are negative 42x. And the 30 does not combine with anything, so it stays that way as well. Remember, your first step in factoring is to look for a common factor. In this case, you're going to say 6 goes into all of it. So the first thing you're going to do is you're going to take a 6 out. 6 divided by 6 gives you the 1n squared. 18 divided by 6 gives you 3n. 108 divided by 6 gives you 18. All right. And then I'm going to factor from there and say, what are the factors of 18 that will multiply to give you a negative 18, but will add to give you a negative 3? And so we're going to say, well, negative 6 and positive 3 will do that. So I'm going to leave this 6 out here. I'm going to say negative 6 and positive 3. They multiply to give me 18. They add to give me negative 3. So that's how I'm going to list it. In minus 6, in plus 3. And that one is factored completely. That's what you would do for something that's like 3. If you look at 53, this is 4 of them. You're going to factor by grouping. But again, your first step is to look for something that's in common. So if you look between all of these, you should notice that a 2 is in common. And so I'm going to say, well, if I take a 2 out, 50 divided by 2 is 25. 10 divided by 2 is 5. 20 divided by 2 is 10. And 4 divided by 2 is 2. And now I can factor by grouping. Remember, grouping just groups the first 2 and the second 2. So I group these 2, group these 2, and remember, if you group behind a negative, you change the second sign. I'm going to leave the 2 all the way on the outside here. And now I'm going to look at this first group and say, what can I take out? Between the 25 and the 5, I can take out a 5. And between my variable, I take out my lowest, which would be the squared. 25 divided by 5 is 5. I took 2 of my 3 v's, so I have 1 v left. 5 divided by 5 is 1, and I took all of my v's. In my second group, between the 10 and the 2, I can take out a 2. 10 divided by 2 is 5. I still have a v. 2 divided by 2 is 1. And then I am going to leave this 2 again. And I'm going to say, what do I have in common? Well, I have that whole group in common. The 5v plus 1 is actually in common. What do I have left over when I take it out? I have a 5v squared minus 2. And now I have factored this one completely. Again, your first step's to take out a common factor. What's in common between 80 and 45? Yeah, 5. And in 0 or 5, it's a 5. All right, so if I take out a 5, I'm going to get 16 n squared. And if I take out a 5 here, I'm going to get 9. So now I'm going to say, well, that's what I have left over. So the only thing that can happen here is, can it be a special case? A special case would be if this is a perfect square. So is 16n squared a perfect square? Does it have a square root? Yeah, 4n. And if this is a perfect square, does 9 have a perfect square? Yeah, it's 3. And if it's subtraction, all right? So the square root of the first guy is 4n, the square root of the second guy is 3, and it is subtraction between them. That is a special case. So I'm going to leave my 5 out here. I'm going to use those two and do plus and minus. 4n plus 3, 4n minus 3, special case. If it had been plus, or if those had not been perfect squares, I actually would have been done that step ahead. In this chapter, the first thing we did is just simplify them. Your index is 2 if you don't see one. You are going to use a factor tree here. So, if I use a factor tree, I'm going to say 1, 128, 1 here. It's basically 2 to the 8th power, I believe. All right. If you know your square root, 256 is a perfect root. 16 is the square root of 256. But if you don't know that, do factor tree. So anything that pairs up can come out. This 2 pairs up, it can come out. This group of 2's pair up, that can come out. This group pairs up, it can come out. And this group pairs up, it can come out. So no numbers actually are staying in right here. Then I am going to look at my variables. For the x, I have x to the 4th. And for the y, I have y squared. We're going to use our little rule, divide it. 4 divided by 2 is 2 with a remainder of 0. 2 divided by 2 is 1 with a remainder of 0. So that means 2 x's come out, 1 y comes out, and none of them stay in. So actually nothing is going to be inside my root here. Everything comes out. And so if I have this, 2 times 2 times 2 times 2 is 16. X squared, y. That is my answer. For this one, you technically are multiplying your insides, but instead of multiplying 30 and 48, which are 2 rather large numbers to multiply, I'm just going to use factor tree right away. I'm going to say 2 and 15, 3 and 5. That's, he's done. 2 and 24, 2 and 12, 2 and 6, and 2 and 3. All right. And so for this one, I'm going to see what groups. Well, I have a group of 2's here, so a 2 is going to come out. A group of 2's here, so another 2 is going to come out. I actually have a group of 3's. These group, so a 3 can come out. And then what's left over is 1, 2, and 1, 5 that do not group. And so once I figure out what groups, 2 times 2 times 3 is 12. 2 times 5 is 10. This next one is just distribution. So remember, insides, insides, outsides, outsides. We don't multiply from in to out. So I'm going to multiply the square root of 7 times the square root of 21. So you're going to end up multiplying the 7 and the 21 because they're both on the inside. Plus the square root of 7 times 3. Well, 3 is on the outside, 7 is on the inside, so I cannot combine those at all. So now my only goal is to decide if I can simplify this 7 and 21. And so I'm going to do exactly what I did over here at 65. I'm going to say, well, the 7, well, that only has one factor. It is 7, right? The 21 has two factors, 7 and 3. So something pairs up there. What pairs up?
7.
So the 7 can come out. The 3 will stay in. Plus, I still have this 3 square root of 7. Can I combine those two? No, my radicals are different, right? One has a 3 and one has a 7 on the inside. So that is my answer. I can't do anything else with it. All right, so when I have division, the first thing I'm going to say is, can I reduce my outsides? Can 5 and 7 reduce? No. Then I'm going to say, can I reduce my insides, 2 and 3? No. Can I simplify the insides? Can 2 simplify in any way? No, it's already prime. Can 3 simplify? No. So now my last step is to just get that 3 out of the denominator, that radical. So I'm going to multiply the top and the bottom by that radical. Remember, when you're multiplying radical, you're multiplying insides to insides. The 5 is on the outside. The 5 is going to stay on the outside. 2 and 3 are on the inside, so I'm going to multiply 2 times 3, which gives me a 6. On the bottom, the 7 is on the outside. And I am multiplying a radical by itself. What happens when I multiply square root of 3 times square root of 3? It just comes out and becomes a 3. Right? It comes out. I can simplify the bottom, though. So my 5 square root of 6 stays the same. 7 times 3 is 21. I cannot reduce the 5 and the 21 because they don't reduce. Why can't I reduce the 6 and the 21? 3 goes into both of them. One's inside, one's outside. Okay. You can only add them if they are like. Are those alike? No. So I can first say, well, right now I cannot add or subtract them. Are they simplified? All right. 54 is not simplified. So I'm going to use my factor tree. 2 and 27, 3 and 9, 3 and 3. Now the 6 is simplified because it only has a 2 and a 3. So nothing's going to actually be able to come out of that one. But this other one, a 3 can come out, right? So I already have a 4 out, so that's going to stay out. I can take this 3 out, and then I have a 2 and a 3 on the inside. Minus the 5 square root of 6 cannot simplify. I'm going to simplify this more. 4 times 3 is 12. 2 times 3 is 6. Now, can I subtract them? Yes, they are like radicals. All right, so I'm going to subtract 12 minus 5. That gives me a 7 square root of 6. And I am done. All right, first thing, when you have a right triangle, you have Pythagorean Theorem, which is a squared plus b squared equals c squared. The key here is to know which one is c. C is always the guy opposite your right angle. So in this case, the 15 is your c. So we're going to label it. So then that means the other two are the a and the b. So when I plug this in, I will say x squared plus 12 squared equals 15 squared. Leave the x squared alone. 12 squared is 144. 15 squared is 225. When you subtract it from both sides, you're going to get x squared equals 81. So if x squared is 81, what is x? Square root of 81. What's the square root of 81? And that is your answer. So if you're answering the question, can it be a right triangle, then you are going to take the two smaller ones, and those will be your A and B, and your longest one will be your C, and you're going to see if it works. So you're going to say, well, does A squared plus B squared equals C squared work? 81 plus 144 equals 225. And then 225, well, helps to write it, right? Equals 225. So yes, this is a right triangle. That's really all you're doing. You're just given the three numbers and you're telling me if it works with the Pythagorean theorem. The distance formula is basically the Pythagorean theorem. So if you have a picture like this, it's basically asking what the distance of that line is, which is a squared plus b squared. And you want to give me c squared, right? But if you don't see it on a graph, you have to subtract your x's and square it, which is your a squared. Subtract your y's and square it, and then take the square root. That's where we get the distance formula from. So if you have a picture, you can just calculate it. You can just say, oh, well, that's 1, 2, 3, 4, 5. That base here is 5. And then you can say it's 1, 2, 3. That height is 3. And I can just plug it in. A squared plus b squared equals c squared. 25 plus 9 equals c squared. 34 equals c squared. So square root of both sides. Square root of 34 is going to be my distance, right? So if I have a picture, I can just use Pythagorean theorem. It is the same thing, square root of 34. If I don't, then I'm going to plug it in and just subtract them. I'm going to say, well, 8 minus 4, that's going to be my base. Negative 5 minus a negative 2, that's going to be my height. And take the square root to figure it out. 8 minus 4 is 4 squared. Negative 5 minus a negative 2 is negative 3 squared. So I get, should be 5 here. 16 plus 9. Square root of 25. My distance here is 5. By factoring, if it's already factored, you just set each one of these equal to 0. 3n minus 1 equals 0. N minus 4 equals 0. And then you solve. Add 1. 3n equals 1. Divide by 3. N can equal 1/3. Over here, you're going to add 4. And then n can also equal 4. So when it's factored, it's really simple. When it's not factored, you're going to do exactly what you did back at the factoring chapter. Factors that multiply to give you a negative 28 and add to give you a positive 3. What are they? What multiplies to give you 28 and adds to give you a 3? 4 and 7. Which one's positive? Which one's negative? You want a positive 3. There you go. So you're going to say v minus 4, v plus 7. And then you're going to set each one of those equal to 0. Right? Subtract your, or add your 4 rather. So v can equal positive 4. Subtract your 7. So v can equal negative 7. Solving by taking the square root. You want to get the square by itself. Right now, the r squared is not by itself. So we need to subtract this 3. So we will get that r squared equals 26. Then we take the square root of both sides. R equals, 26 is just 2 and 13. Nothing simplifies. But you do need to tell me it is the positive and negative root of 26. Negative b plus or minus the square root of b squared minus 4ac over 2a. By the way, if it is just x squared or just x, your a, b, or c is a 1. Some of y'all put the variable there. Variables are not in the quadratic formula. You are finding out what the variable equals. It's only numbers. So negative b here is 6, so negative 6. Plus or minus the square root of b squared, that is 6 squared, minus 4 times a times c. All over 2 times a. Then simplify. So we're going to say negative 6 plus or minus 6 squared is 36. We have negative 4, positive 3, and negative 10 is going to give us a positive 120 over 6. We're going to add those and then simplify as well. Negative 6 plus or minus 36 plus 120 is 156 over 6. You do need to figure out what that is. So we're going to do just like we did in the other chapter. We're going to do our factor tree. 2 goes into it 78 times. 2 goes into that 39 times. Then you're done. All right, so a 2 is going to come out. So I'm going to say negative 6 plus or minus.
Isn't 39 divided by 3?
Yeah, but it doesn't. Sorry, I guess I keep going. It doesn't do anything. 3 and 13. So I knew it was prime. Sorry. But yes, you're correct. A 2 can come out. The 3 and 13 stay in. So it's 39 on the inside. And then a 6 here. Some of y'all reduced wrong on all of your quadratic formulas for this thing. You cannot reduce just the 6 and the 6. It has to reduce with everything on the outside. So what goes into 6, 2, and 6? 2. So you have to reduce them all by 2. 6 divided by 2 gives me a 3 there. 2 divided by 2 gives me a 1 there. And 6 divided by 2 gives me a 3 there. Some of y'all just did the 6 and 6 and then just gave me this weird positive or negative 2 square root of 39. You just like ignored that 6 and 6, right? So that is not correct. This guy is correct.